Hello, and today's demo we're going to create a streaming source. So just to recap on what we've done in the previous demos, so far we've created a data pipeline which contains a single static source which is pulling data from S3. It contains a transformation which is running a SQL on the data from our source, and then we are outputting that data into a sink, which is a local file. So in order to add a streaming source, we first click on a source component and drop it onto the GUI interface. Let's go and change its name to something more appropriate. So let's prefix it with a source because it is a source. It's going to be streaming. So let's add stream in there. It's going to be pulling data from S3. And then finally, let's add a description which indicates the type of data or the file that we're pulling from, and it's sensor data that we're pulling from. So let's put that in there. Next, we're going to select the playbook subtype. So I've already said that we're going to be generating an S3 stream, so select that. Finally, the source type or the file type that we'll be reading is CSV, so let's select that. So once we've done that, it then populates the key value pairs for the playbook components. So let's start walking through this and populating it. The first one is location. So this is fairly self-explanatory. We need to enter the location of the bucket on S3 that we want to pull all data from. So let's copy that in, and let's find the file that I want to copy from. And it's here. Okay, and let's put it in there. That's fine. Next key value pair is the max files fetch. Now, when we're reading any data, so whether it's streaming or whether it's static, for a file system, we can define the number of files which are read in one instance. So for every iteration, how many files will be read? That can be either 0, which means for every iteration, whenever you're executing that source component, read all the files which are available within that bucket, or we can specify a number. So if there was 100,000 in there, then it would only read 100,000 files for each iteration, so every time that source is executed. For this particular example, I'm setting it to 0. Next is checkpoint source. So one of the key features of a streaming source is the ability to recover from it and also to remember what files have been read. In order to do that, we have to create a checkpoint. So this is where the state of which files have been read is actually physically written out and stored somewhere. So to do this in IOblend, we have to first say, well, where is that checkpoint source file going to be written to? And it can either be a local file system or any file system within the cloud. For this particular example, we're going to be writing the checkpoint to S3. And then next we have to enter the bucket location of where that checkpoint is going to be stored, and also the name of the checkpoint as well. So let me just copy the one that I have created previously. Just copy that and drop it into the key value pair. Okay, so we're good to go. Next key value pair within this playbook is relocate. So as mentioned previously, one of the design principles that we had with IOblend was to add as many of the production grade functions that need to be in a production data pipeline. So things like relocating, data lineage, archiving, slowly changing dimensions, metadata management, error management, all of these things which you typically have to write a pipeline to do as part of your business data pipeline. We've created them as standard functions and features within IOblend. So here relocate is one of those. So one of the things that we can do is once a file or several files from a bucket has been read, irrespective of whether it's a static or whether it's a streaming source component, we can specify whether we then want that file or those series of files moved to somewhere else. So if we specify relocate to true, we then have to give it a type. So that's either a local or, again, a file system within one of the cloud environments, and then a location. And every time it reads that file, it will automatically move it. For this particular instance, we'll leave relocate to false, as I don't want to move them. Now, as explained in previous demos, whenever we read data from a source, what actually is happening internally is that that data is stored in an internal table that IOblend creates. So every time we go through an iteration and new data is read, that new data is added to that new internal table. And the name which is given to that internal table is the name of the actual source itself. Now, sometimes you want to be able to quickly access the new data which has been read in from an iteration. IOblend makes this easy by automatically creating an additional table which will store just the new data which has been read from the source for that iteration of that data pipeline. So if we want to do this, then all we need to do is set store new record set to true, which we're going to do, and then provide a name for the table that will store just the new records. So every time it reads data from source, these records will be wiped, and then the new records will be added to this table. So I'm going to call it the same name as the playbook name, but then just postfix it with new. Next value is dependencies. A dependency is the predecessor of the existing component, which has to run before the component in question can be executed. So in this example here, my transgroup sensor actually has a dependency of on source S3 static sensor 01. And what that means is when the data pipeline is executing, transgroup sensor will not execute, and subsequently nor will sync local group sensor execute until source S3 static sensor 01 has read new data. So in the case of our new component, its dependency is itself because it is a source. Another key feature that we've added to IOblend is the ability to automatically dedupe new arriving data against the data which has already been read. So if you want to do this, we have to set this to true. Then enter the keys of the table which will be used to dedupe it. So this is typically the primary keys. So source stream S3, so this data here, I know that the primary key is actually device ID. We'll use that. And the version keys are the collection of keys or composite keys, which then make that maintained underscore keys, in this case device ID, unique. So we can use that version keys to identify when a record is changed and it is new. So for this example, I know that my version keys are temp, heart rate, and created date.